Hey everyone, welcome to Tanzu Tuesdays. Today I have Dan with me. I don't know if you've met him yet. So Dan, want to give a quick intro since you're still pretty new? I can't, you're muted.
There we go. Sorry about that. Yeah, so I've been here about 2 months now. Seems like much longer than that. We worked on so many cool things so far. So yeah, I'm a developer advocate, mainly focused on Spring. So anything in the Spring ecosystem, I am putting out content on, working on different workshops and videos and blog posts, etc. So excited to be here and excited for our talk today because Kubernetes is one of those things that I'm continually trying to learn more of. So anything in that world, I'm excited with everyone that we have here today to learn from them. So I'm just going to be a sponge on the wall today.
And speaking of spring, so we have this like roadshow style thing. It's that Spring One tour. It's been a thing for several years, but we're finally going back to real places instead of just virtual. Our first one will be in Chicago from April 26th to 27th, which is like in a month, kind of crazy. If you go to springonetour.io, you'll see all of our upcoming ones, and I'll post that in the chat. But yeah, in-person things, yay!
Yay! It's gonna be so great to like see our team together.
Yeah, since we both started during the pandemic, it's like, who are you?
Yep.
All right,
We should
so
also mention
today,
tomorrow we have a
oh yes,
free
.NET.
two-day .NET Conf coming. If we go ahead and get a link and put that in the chat.
Yes.
But this is 2 free
.NET
days of .NET content with some really amazing speakers, and I'm get to help out on that. I'm going to help moderate some chats, so I'm excited to sit in on some of those conversations as well.
And there's 2 different days with totally different time zones, so anyone can pretty much attend. Like the first day is like my U.S. time zone ish, maybe more Eastern time zone,
Yep.
and then there's one for like Europe. So
Yep.
yeah, just definitely go check that out. It's gonna be super cool. I think that's it for events that I can think of right now. So with that, let's introduce everyone that we have today. So first, we have Robert.
Hi guys.
Scott.
Hey everyone.
Myles.
Hey there.
And Steve.
Hi.
So you may have seen some of these people, some of them are new. Thanks for either coming back again and enduring us, or good luck on your first time.
It's always great to be back.
Maybe if you all could say maybe just like a little bit about like what you do and like who you are.
Yeah, okay. I'll start. I'm Robert. I work for ITQ. We're a VMware partner, and I'm a technologist for Tanzu at ITQ, which means I focus on basically everything around the Tanzu portfolio, especially TKG. And yeah, I've been with ITQ for about 3 years, and I'm pretty new still to DevOps, to this cloud native stuff. Still a bit of a Kubernetes noob, so I'll probably be asking a lot of questions, and hoping other people can answer them for me. But I bring about 10 years or 15 years of infra experience with me. I've been through just about every VMware product you've heard of. So I like to approach this whole thing from that perspective.
Awesome. And I'm Scott Rosenberg. Had the privilege of being here a few times recently on Tanzu Tuesday. I work for Terra Sky, VMware partner. I'm based in Israel, and I lead the Tanzu portfolio in the cloud native world here at Terra Sky. Been working with VMware since 2014, started in the infra world, moved into VRA and automation, and then been really the whole Tanzu portfolio, TKG and TAP, and the whole new portfolio for the last year or two. So awesome to be here.
I'm Myles. I'm coming to you from a 100 to 200 millisecond latency link at the minute. So if I stand on people's toes, I apologize. I work for VMware. I work in technical marketing, and I cover Tanzu application platform at the minute. And my background is infrastructure, same as Scott. I sort of started around 2012, 2013 with VMware technologies, with networking and storage, and gradually got bored of all the underlay stuff and just kept moving up the stack. And here we are today.
And I'm Steve Wong, based in Los Angeles. I've been active in the Kubernetes upstream open source project since 2016, getting started in the initiative to bring in storage plugins and CSI. I'm an engineer on the Tanzu Community Edition open source project. And with Myles, I'm co-chair of the Kubernetes VMware user group. And I'm also tech lead of the Kubernetes IoT Edge working group. Back to you, Tiffany.
Yeah, so I realized that I forgot to run the intro music thing, so no one had to see the Tanzu Tuesdays little thing that happens, because apparently my brain is mush. But
you could run it now.
Just like run it now, and then later like crop it and like shove it in the beginning as if nothing happened.
Yeah.
Oh my gosh. I'll just steal it from one of the other videos. It's fine. Happy Tuesday.
Happy Tuesday.
Yeah. Let's see. I'm in Seattle, developer advocate. Been doing this. Tomorrow will be my 2 years here, which is kind of crazy. So I've survived thus far of pandemic life in this job.
I think thrived is a better word.
Fair enough. That's a nicer thought. But yeah, so how about we get into what all you are planning on talking about, if someone wants to start that up?
Yeah, so it's kind of funny in some ways. This this Twitch stream or this live stream is it's kind of an extension of what the four of us have already been doing recently in the Kubernetes user group meetups, which is we've been talking a lot in the last few months about Kubernetes availability concepts, and it just kind of happened to go down that direction. I can't remember, Steve, if there were specific topics or agenda items that triggered it off, but we basically ended up. I think we've spent 2 or 3 sessions kind of talking about those things. So we thought, oh, why not do it here as well? The idea for me has always been to kind of start structuring it a little bit more. I think all of us have the idea that it would make a pretty good content for like a talk at some point at either KubeCon or VMworld or somewhere like that. I haven't been able to structure it yet. I don't know if any of you guys have. But until we do, we'll just keep talking about it. And I do think that because it's right on that edge where infra and Kubernetes meet, and where a lot of us from the VMware community are, from an experiential side or just from what we do, it's always a fascinating topic. There's a lot of movement in the area around availability. There's lots of kind of stuff in the pipeline and things, kind of fresh coming out of TKG development. So there's always a lot to talk about, and so many people are learning Kubernetes now, really getting into it. The subject availability is really on everyone's lips. So we've got a whole bunch of talking points, really well prepared, and we're just gonna chat about a few of them and see where the conversation goes.
Yeah, I think that one of the big questions that I've been, contemplating for a while, that I've gotten from customers that are asking me, and that I've been contemplating looking through Tanzu framework, looking through Rancher's code, looking through different, distributions running on Kubernetes, is there's this general idea of availability zones, right? When we run in the cloud, everyone says never trust an availability zone, because if you ran in US East 1, I believe it is, on Amazon over the last year, you had quite a few outages. So you wanted to be multi-AZ. And when we bring that to the on-premise world, to vSphere, we may have multiple data centers, we may have multiple vSphere clusters, but the question that I've always been asking, I'd love to, talk about it, is can we actually parallel public cloud and vSphere? Meaning these ideas that have actually been structured in Kubernetes has been built around these ideas of availability zones for clusters and stretching availability zones. Does that stand water on Kubernetes? Can we do that? And what is the actual parallel that we would do if we can?
I think it's funny you start with availability zones, because for me it still feels very much like a public cloud kind of concept coming from infra. We'd use terms like data centers or failure domains. This terminology also used in vSAN, for example. I used to work with EMC vPlex, which did synchronous data, block-based data replication, and within the infra world, really there was if you had replication, if you had redundancy, if you had failover, it was never more than 1-to-1. It was never more than 2 sites. And the interesting thing with public cloud is, that seems to have broken up that mold a little bit, where people just have a whole list of AZs they can start building resources out in. So I'm kind of interested a little bit in the history of how did we get to this idea that that having more than 2 AZs would be normal, even if that even is a normal thing or not, and when do we start seeing application architectures start to make the assumption that there would be more than 2 AZs, and why 3? Why not 4? Why, of course we kind of know, but let's get into the history of that a little bit, maybe.
I think you're onto something there, Robert, and it's kind of interesting that I think one of the both opportunities and challenges that come into the discussions that we've been having in the Kubernetes VMware user group is that there's almost a richness of ways to do things to achieve availability. In fact, perhaps the fact that there's so much creates challenges in that which of them do you choose from? What happens if you attempt to use multiple layers of these availability concepts at the same time? Sometimes that might sound like that's a good idea, but often it isn't if these structures end up fighting each other at different levels, or you end up with a degradation and you're sitting there trying to figure out, gee, what happened? What, sometimes troubleshooting when you've got these different layers of migration going on can be quite the challenge. The interesting thing is that this also presents the opportunity, if you're coming from a background where you achieved your availability through vSphere or infrastructure level components, you're not forced to migrate everything to Kubernetes all at once to achieve availability. And it might be a situation where if you've got legacy, the answer is perhaps don't fix what isn't broken and, move kind of your modern apps platform that was built for running on Kubernetes and in public clouds first, and maybe try to retain some of your persistent storage kinds of services where it's been proven to work. In the long run, you can aspire to migrating them as well to take advantage of cloud native concepts where you might move it across public clouds to get 2 or 3 instead of 1 or 2 potential hosting operations. And in terms of, we had a chat about this just before this session got started in terms of what advantage you might get from having, instead of 1 or 2 potential hosting sites, 3 or 4. I think there might be value in situations where you've got impending outages with notification, like say a hurricane is predicted to hit a city coming, and given a day or two advance notice, perhaps you could pull hosting from Miami to some inland location to trade off, a latency penalty for an availability benefit. And often there's no one right answer, but there are some interesting things, and it's a great area for birds of a feather discussions.
I think like what Robert was saying about the history of how we got here is that, at least from my perspective, enterprise applications and cloud native applications evolved in parallel next to each other, and there wasn't a lot of overlap in the way that they were looking at things. Like if you go into any enterprise, they always talk about availability from an infrastructure perspective. They got replicated storage, multiple clusters, all the rest of it, multiple sites for redundancy, so that their developers could just write apps and let the infrastructure take care of all of the hard stuff underneath, like the data replication, any other complicated mechanics that you would otherwise have to build into the application. But it was exceedingly expensive to do it that way, which is, I think, why public cloud got underway, because if what you wanted was just some hosting somewhere, and you could use your brain and build it into the app to add the intelligence and build one of these cloud native apps, as it were, then it made more sense for you to run in public cloud. And just because of the fact that they had different regions and zones that didn't provide guarantees around really high uptime, you had to build your app so that it could tolerate failures. And that's probably why we saw this divergence. And now what we're seeing is the way of doing it in public cloud with these cloud native apps, and say Kubernetes is one way of deploying those, that it is such an attractive concept, and the way that you can manage it declaratively and such is such an attractive concept that it's leaking into the enterprise, and the enterprise is still in the mindset that they've always been in, that they're trying to say, okay, well, I'm going to protect this the way I've always protected it. I'm going to provide availability the way I've always provided availability. But the two concepts fight with each other, and I think that's probably why we're here having this discussion.
I think Java Grunt raises some good points in the chat, where it's he says his kids will never deploy active passive. They were born into active. A lot of the narrative around public cloud, of course, is that it became big with some of these cloud scale services that we're used to. And we love telling the Netflix story and the Uber story and the Amazon story. And of course, and this also goes to availability. These services service so many people at such a scale, they can never go down. You cannot have a failover moment. The whole thing needs to be distributed by design. And what you see happen is that these you can't rely on deeper infrastructure layers to take care of that problem. It's too slow. It's not specific enough. Enterprises solve it in that way because the expectation was always that infra used to do this. So it's partly a cultural problem, but it's also there's not, in many enterprises, there's simply not enough expertise to be able to build in resiliency at the application level historically, and this is still the case if you ask me. So who else is going to take care of that problem if not infra? Who else can replicate the data? Who else can do the failover of the VM? Who else can stretch the VLAN? So there's a culture gap, there's a history gap, but I don't see that culture difference going away anytime soon. It's very interesting where we are now, where coming from public cloud, taking these concepts along with us to the on-premises data center, and then placing it on infrastructures that haven't grown up around these concepts. So you get this, and this is to Steve's point, you get this very interesting mix, and things don't often match completely, or might even, in the worst case, get in each other's way.
Yeah, I think this whole cloud native, always active concept goes back a ways in the application stack world. If you go back to the 12 factors premises, one of those 12 factors are that all applications or services should be stateless. And, on the surface, it's an attractive concept as an app developer to do that. But ultimately, if you look at the big picture of that all things are stateless, I think it's inherently kind of a fraud, because at some point there has to be persistent storage under the cover somewhere. And it really is a statement that I'm going to just declare state management to be some other person's problem and assign the hard parts to them. And if you're fully in public cloud where you can buy persistent stateful storage as a service, maybe it really is the other person's job that you manage to pull this off. But if you're part of a big picture management of IT in an organization, at some point, at least some people in your organization do have to manage that persistent and stateful storage. So it's no longer the other person's problem. It might be your problem. And, there's not one way of doing this. Even when it comes to those persistent stores, they're kind of the legacy SQL databases that were done in that world, where you would take snapshots, do backups, have online snapshots for rapid failover recoveries, and kind of this closer to born in the cloud stateful clustered storage like Cassandra, MongoDB, things like that, that do anticipate being spread across multiple cluster nodes, where you could take any one of these nodes, or maybe a few out behind the barn, shoot them in the head and not take a major disruption. You have to look at this, and I think many in the audience might be the person whose name is on managing stateful store, and Kubernetes and multiple public cloud availability zones didn't necessarily solve all the problems.
Yeah, and what's the famous line? There's no such thing as a cloud. It's just someone else's computer. Right? There is the interesting thing is that I think what VI admins are dealing with today of trying to understand availability zones, it's not that doesn't exist in the cloud. That's just Amazon, Google, and Azure, and Microsoft, and Oracle, and whatever cloud's issue. It's not yours. It's their issue. But they have the same issues as we do. In the end, you have the same infrastructure challenges, I think, as the public clouds do, and they've just built an abstraction layer above it. And I think that that's where the real interesting thing is we're looking in, the market today of what's running on Kubernetes, whether it's cluster API based or Bash based like TKGI is, or other solutions that are out there that are trying to build this almost like a middleware above the infrastructure. If we look at like Portworx, who are trying to do this on the storage level, where Amazon has built for us in like AWS a middleware between the infrastructure complexity and our applications. And it seems that that's where the market is going also in Kubernetes on-premise now, where we're trying to build this middleware that'll deal with resiliency, that will deal with high availability, multi-AZ types of solutions. It's still very young, it seems, that world, though. And I know that I've had this conversation multiple times with customers of back if we look at the original VMware offering of Kubernetes, which was PKS, now TKGI, or today in the TKG offerings where we have machine health checks. In Bash, we had the idea of Bash reconciliation, right? Where they would automatically reconcile things for us. If a VM went down, we got high availability, not necessarily at the regional level, but if my node went down, it made sure it came back up. And we're seeing all this stuff happening. On the other hand, because these aren't built by the same team, let's say, Amazon is one platform, and here you have multiple platforms. Unfortunately, what we see a lot of times, that platforms actually interrupt one another. And you have vSphere HA fighting with Bash, or vSphere HA fighting with machine health checks. And it seems that the market is everyone is trying to reach the same thing, but shooting in 100 directions, that it's very hard to figure out what the actual right solution is, because there's 100 answers to the same question, and everyone is 80%, 90% there. No one's 100% there. So there's no actual best solution.
Yeah, I think the challenge as well is people look at something like, for example, vSphere HA is a highly availability technology that we have built into the platform. So you think, right, availability technology, let's add that to our stack that will make us more available. And then they go to the Kubernetes layer, and then they've got, replica sets or daemon sets or whatever they choose to add more replicas of their application and distribute it across nodes to make it more available. And they add 1 + 1 and they think 1 + 1 = 2, when in reality 1 + 1 does not even equal 2 in this case. They, like you said, Scott, they're going to fight each other, and you're going to end up with the weirdest edge case, corner case failure scenarios that you've never thought of, because app lives on node over here, which is on a different physical host, but there's no awareness the whole way through to the chain as to where that lives. So maybe some of the technologies that we've always had in vSphere and taken for granted, we might want to turn off, or just pin them to specific nodes. For example, if you have a Kubernetes cluster that is 3 nodes and your vSphere cluster is 3 nodes in size, typically anyone that deploys vSphere will use DRS, the distributed resource scheduler, to just say, shuffle these around and make them fit wherever they fit. And that's good enough for VMs. But when you're talking about a clustered solution, really you want those things pinned to hosts. It's not going to be ideal from a resource consumption perspective, but at least you have predictable failures. And maybe that's more important than having that availability technology at the underlay.
There's also the point that that as you get higher up the stack, more closer to the application, the more specific you can be about failover and resource scheduling. So I mean, vSphere does DRS, does resource scheduling really well. It does HA, very well, but it's made to do that on the object of the VM. So it's pretty bulky when it comes to that. I mean, go further back. The stuff I used to work with was doing it at the storage level, mostly the replication part of it, or taking LUNs offline here and putting them up over there, that kind of stuff. Even deeper down the stack. The deeper you go, the more bulky it gets. The more the less specific you can be about what it is that's in the layers above. You start to take more and more responsibility on board, but you have to kind of treat everything the same. Otherwise, you could never make it manageable. With Kubernetes, I mean, the kind of the first thing that struck me was like this thing is able to spin up pods way faster than HA could ever spin up a new VM. I mean, so just thinking from a kind of an efficiency perspective, who is able to deliver a faster kind of failover, of whatever it is it's trying to spin up again. And the answer there was obviously Kubernetes for the pods, right? I mean, if you take it even higher up the stack, and it's kind of where my knowledge ends. But if you think about state and about sessions and about where things land in a front end or a middleware or a message bus architecture, you'd be able to deal with resiliency even more effectively. It's probably how services like Google work. So we kind of, if the point is to develop more cloud native types of application architectures, then we're going to have to let go of some of these ideas we had, that the safest place to do X, whatever X is, whether it's failover or scheduling or replication, is at the infra layer. Because the other layers are going to be more efficient at it because they're closer to the actual thing that matters, which is that the service that's actually being consumed somewhere, or the piece of data that actually needs to get to a user somewhere. You're gone.
Oh, I wanted to throw out a question comment to you, Robert. I'm not claiming to be an expert on this, but this is a situation where not everything is the same if you're running exclusively in a public cloud versus on-prem. And if you're in this scenario of on-prem edge with limited resource and maybe not the redundant levels of power that have in a public cloud scenario, one failure scenario is power goes completely out in the data center, then comes back. I think that there's a contention that maybe in that scenario, Kubernetes isn't the faster recovery, in the sense that there might be some steps required to boot up the Kubernetes cluster that need to come available sooner than others. For example, a container image registry. If those things were to be hosted entirely as a, if you were to host a Harbor container image registry as a VM, not running in Kubernetes, I think that is likely to boot much quicker than putting it up at the Kubernetes layer. And maybe there's an argument that some of these precursors that are kind of the building blocks of booting your Kubernetes, like the image registry, let's say the authentication source that holds your users and groups and authentication, you really want to get those back quickly, DNS, that maybe hosting these as containers inside Kubernetes isn't a one size fits all, and that you'd be better off to run them at the VM level with the availability features of vSphere turned on, just so that these early requirements would be on the air early, and then Kubernetes gets itself up after that. What are your thoughts on, is that crazy talk, or does that make sense?
I think it makes perfect sense. It's the same argument I've heard for a long time in regards to VMs, right? VMs take a while to spin up. So you lose power, you lose a bunch of ESX hosts, and you lose 100 VMs, 200 VMs. And to get all that back takes time. So I've heard the argument put forward, well, the most essential services we have, like Active Directory or DNS, whatever it is, well, that should be on bare metal, because there at least we press the on button and we know that within X amount of time, 10 minutes, we have DNS back, no questions asked. There's not an additional thing in between that might fail in some way we couldn't predict or was unexpected. And of course, with Kubernetes, we've added layers, because Kubernetes are usually going to be running inside a VM. So we're adding additional risk that some effect that we didn't anticipate is going to delay whatever it is we're trying to run inside Kubernetes coming up. Now, of course, you can play around with things like, well, this Kubernetes cluster should come up first, right? So we'll give those VMs the priority, or we'll have them running on a separate ESX cluster, and that one comes up first. You can play around with this as much as you like, of course. But I think your point is incredibly valid. It's not something that's often thought about enough in availability design, because, of course, the interesting thing about availability design is you have to take the whole stack into consideration. It's not just, it's not just an ESX host you're going to lose. You might lose a whole data center, or just a partial one, which are sometimes interesting scenarios as well. So it's not crazy talk at all. It's I think the more layers we build in, the more we have to actually start thinking about this. And in some cases, sometimes the design is just over complex, and we'll need to simplify. The really important stuff might have to be simpler in order to make it more robust.
Yeah, I know, Scott, you made a comment before at the user group meeting that when you do this, you split things between Kubernetes and the infrastructure layer, maybe a little bare metal. That one thing to create the illusion that these things are unified is maybe to unify your logging, your metrics, your observability, so that troubleshooting can go to one place and go find all these things that might be coordinated. But go. Sorry, I interrupted you, but.
No, I think that's completely true. And I think that, anyone that comes with the idea that everything should run in Kubernetes, I have a large argument with them, because there are things that are meant to run in Kubernetes. There are things that are still meant to run on a mainframe. There are things that should be in VMs, and there are things that should be bare metal. I worked with a customer on, evaluating different Kubernetes solutions, and they were using Aerospike just as an example for an application with pass-through NVMe, special devices. I'm working with the vSphere performance team. Working for months getting this, and there was still a performance degradation that was very high relative over bare metal. Now, when he ran the Apache or Tomcat or Postgres server, there was almost no degradation, because there are certain applications that purely need to run bare metal just due to how they work. There are things that need to run in VMs just to how they work. They aren't built for this idea of Kubernetes. And what we need to do is bring this unifying layer above, monitoring anything in the observability world, right? Anything in the security world. But one of the things we're seeing with tools, whether it's things like Carbon Black, Aqua Security, Prisma, right? All of these tools are now cloud security and container security. It's none of these tools that are just a container security solution, right? It's how do we build a solution that can actually give us this end-to-end visibility, because we will continue to have both. The legacy will stay with us, right? And it's fun to call legacy what we called 2 years ago, the cutting edge new technology, and now it's already considered legacy. EC2 instances brought up through infrastructure as code on Amazon is now legacy, because it's not a container. But I definitely think that, that's where we need to reach. And about what you had mentioned, Robert, about the idea of, okay, we can set up maybe a Kubernetes cluster that these nodes come up first or these ones come up after. I think one of the hard things when it comes to availability in Kubernetes is that nearly every Kubernetes distribution today that's coming around is using the Kubernetes approach of saying infrastructure is immutable. Our VMs are immutable. And by saying that, it becomes very difficult to tie a VM that in 5 minutes may not exist to a host, when what's the chance of that VM actually existing in 5 minutes? And if an ESXi host goes down, and before vSphere HA even gets time to power up the host and the OS boots and everything, Cluster API notices, hey, this node isn't responding. It deletes the VM from vSphere and creates a new one. And that's a really interesting thing that is affecting this talk about availability. Because if we were talking mutable VMs and they were persistent virtual machines, things become really easy, I think. Because you go into vSphere client, even if it's manually or through Power CLI or whatever you want, you pin them to hosts, you pin a third to this host, a third to this host, a third to this host, and you've got your availability zones within the cluster, and you've got a solution. We're now talking about VMs coming up and down. Auto-scaling is on vSphere now with Cluster Autoscaler. You've got nodes coming up and down every second, like you have pods coming up and down. And I think that just, again, shuffles all the cards and makes it, on one hand, a lot easier because you don't need to deal with it. On the other hand, much more difficult when you have that mission critical application that can't suffer the downtime.
But then if there is that mission critical application that can't suffer the downtime, being devil's advocate here, and it is running on Kubernetes, should it not be written differently so it doesn't rely on a single cluster and instead is multi-AZ? And if so, why would you do it that way versus just leaving it in the VM and using a traditional stretch cluster and the way that you've always done it? Because there are two different ways to approach it.
I completely agree. I think there are applications that need to stay out of Kubernetes, not because they aren't good containerized, but possibly because the tooling isn't there yet. I think that the ecosystem is moving forwards. And one of the things that I love about Kubernetes is how many alpha and beta APIs there are out there. And a lot of people hate that. A lot of people say, give me GA APIs. What do you mean? I don't want to be using V1 beta 1 of Ingress for 4 years that everyone has been using in production since before it was even beta. But people want the GA APIs on one case, which makes sense. And we've heard that around Tanzu as well, with all these alpha APIs and things like that. On the other hand, it means that things are getting into the real world scenarios early enough that they can actually still be changed. When we look at the traditional commercial product where something would get into the end consumer's hands after years and years of development and was already GA, engineering and the real world use cases don't always go hand in hand, because what they have experienced is not necessarily what customer A, customer B, customer C is doing in their environment or what types of applications they have. And having this idea of alpha and beta out there in these systems is amazing, but you still need to be careful about using them. Having that capability is great, but you have to do it with concern, with a lot of careful thinking. And that's where I think that what you're saying, Myles, is 100% true. Certain applications, even if they are good to run in Kubernetes, the tooling may not be there yet. And just because there is tooling doesn't mean it is actually viable at this point for those types of applications. Maybe we wait with those.
When all you have is a hammer.
Yeah.
So
Exactly.
so let's get into the weeds a little bit about some of these specific technologies. You touched on it. We touched on it a few times. Stretch cluster, popular concept from the vSphere world, from the vSphere ecosystem. Did stretch cluster on EMC hardware. We can do it in vSAN. So why? So what's the issue with running Kubernetes on stretch cluster?
I have many opinions about this. There are lots of reasons why you shouldn't run Kubernetes on stretch clusters. And I think chief among which is stretch clusters were great for what applications they were designed for, which was your standard single node Java, .NET app, whatever. The only availability that was ever expected from it was what the infrastructure provided. And that's why stretch clusters exist. And those infrastructure teams, if you know, they've been maintaining those things for 15 plus years at this stage. And you know, that's what they know. So they see a new app come along and they say, I know how to protect apps. I put it on a stretch cluster. But like we said earlier, availability technology plus availability technology does not equal more availability. Sometimes it means less availability just through complexity and you know, non-deterministic startup procedures and stuff like that. So when it comes to storage, in particular on Kubernetes, there's a couple of ways of looking at it. If your apps are just, you know, Microsoft SQL or just any kind of flavor of standard single node SQL, that database does not belong in Kubernetes. That should probably stay in a VM somewhere, and that could live on a stretch cluster. That would be okay. But the Kubernetes cluster itself, if you're running something more complex in it and more cloud native from a data perspective, something like Cassandra or Mongo, or you use message queues or, you know, Elasticsearch or anything that does its own sharding and distribution, then you probably don't want that on a stretch cluster. And you don't want that on Kubernetes on a stretch cluster in particular, because stretch clusters are, like you said, Robert, earlier, they're a blunt tool that does something well, but that is the problem. They are very blunt. They're indiscriminate as to how they take action. So if there is a failover event, everything gets treated the same. Everything gets failed over and started up the same. But those two sites might be different from a Kubernetes perspective. More often than not, you don't want your whole Kubernetes cluster, including, you know, control plane nodes, failed over all at once. For example, there's lots of problems with etcd whenever you have simultaneous failures and stuff, especially when you use a cluster API to spin them up. There's some nasty bugs in there. And that's why we have this clusters as cattle sort of mentality, or you should, if you're really seriously considering Kubernetes, you should treat them as cattle so that you don't have to deal with the edge case around, oh, my etcd cluster simultaneously shut down and now there's a quorum problem on the other side. You should have the application split across both of them. And if the cluster is dead, fine, spin up a new one, or have your GitOps instance spin up a new one for you. You know, there are other ways to solve these problems than just letting that hammer that you've had try and solve that.
So do you think then, Myles, that you should have multi-AZ clusters, or should you have multiple clusters each in a single AZ?
So the way I would architect it, and this comes back to if the tooling was there today, is I would have multiple completely distinct Kubernetes clusters with completely distinct control plane nodes. They do not co-locate with each other. They're on separate physical sites, and there is some kind of layer on top that puts the same of both apps on both sides. And then your persistence is maybe, the persistence layer is where that might get a little bit more confusing, or maybe you have a multi-AZ cluster just for your persistence layer. But anything above that, anything that doesn't require persistence, to me, keep them totally distinct, keep them separate. It just simplifies everything. But as we all know, once you get into state, then it gets really muddy.
So something like a KubeFed version 8 when it becomes, ready.
Exactly. Like KubeFed, I'm a big fan of the idea of KubeFed. I think that's a really, really nice idea. And having federated CRDs that replicate to clusters, that's a great idea. And to me is probably the way that we need to go if we want to have multiple distinct K-8s apps. But from like an app architecture point of view, it's more complicated than that. That sure, that'll replicate your CRs, but that doesn't help you figure
discovery.
out exactly. There's a lot more dimensions to it, and like you say, I just don't think the tooling is totally there today.
Yeah, I think there's a lot of amazing tools. Each one does something else, though. Right? You have Tanzu Service Mesh or HashiCorp Console that can do multi-cluster service mesh. Okay, that's one side of it, but how do you deal with distribution of load between clusters? How do you deal with failovers between clusters? How do you deal with all this? And there's too many tools that you need in order to solve one solution, and they don't integrate with one another yet.
Yeah. That's why you need a platform.
Yeah.
I'll go on, Steve.
Oh, so I was going to ask a follow-up on this: too many layers, too many tools. Is this a scenario, working for VMware? I hate to sound like a shill, but it strikes me that there are historical analogies when you had virtualization and hardware, both of which could have failures, and it resulted in integrated solutions for customers like vBlocks, where you could sort of outsource this complexity by throwing it over to a vendor's responsibility and ending up with one throat to choke. To what extent are you able to offload some of this complexity on a vendor or service provider today to kind of integrate your infrastructure, your Kubernetes layer, maybe even your app layer? Anybody got ideas on that?
I think there is a perfect answer to that, in my opinion, that many will disagree with, but Myles will probably agree with me due to his new position, which is that I think that Tanzu Application Platform is exactly an example of the direction things need to go in that world. Where if we look at the idea of vBlock, take the idea of PCF or TAS as an example there. It is a curated solution that does what it is supposed to do very well. And it is this black box solution, though. It is, great. I have no clue what goes on. I have no clue where the hardware and the virtualization end and where the border is. This is the product, and there is one call line that you call, and everything is great. In today's world, in the cloud native world, as scared as I am every time I open up the CNCF landscape, which yay, Cartographer was added to there. Shout out to the Cartographer team. But, it's scary how many things there are, but people are not, companies, customers do not want to be told anymore, you have to use this opinion. You have to use this tool. And that's where the idea of opinionated defaults or sane defaults with pluggability from a single vendor is where things need to go, right? Tanzu Application Platform comes with a solution for networking, for ingress, for all of these things, right? The same thing could exist in the world of, multi-cluster availability, hopefully will. But you can't lock in any of the multiple solutions you bring in. We were talking about it before. There are 13 open source projects built into Tanzu Application Platform, but I can tear out 12 of those and it still works and replace 12 of those. One of them I can't. Cartographer is the base of it all. If I get rid of that, I don't have Tanzu Application Platform. But anything else I could tear out, replace with something else, and it would still work. And that's what we need, I think, in the availability world. There's some things moving in that direction, I think. But it's still a very young age. But I think that's where it needs to go, the pluggable, opinionated manner.
Yeah. There are some products out there, like you've got Crossplane that does a similar sort of thing, and there's KubeFed does that kind of multi-cluster stuff. And like you were saying, TAP does a part of it, but then there are other, like the multi-cluster stuff in particular, that needs and probably will have a solution in the next year or two, if I'm honest. If you look at the rate of development of commercial products in this space, I really wouldn't be surprised if this was a quote unquote solved problem in the next year or two. And maybe what we're talking about is redundant by then, which is fine, but these are still real considerations that you need to make today. But just throwing something at a platform, say like TAP, doesn't solve your availability challenges that you might have. Yeah.
Right. Exactly. But that approach that was taken in TAP, I think, needs to be taken at the, let's call it that was at the application level. We need this at the infrastructure or platform level. We need a Tanzu platform almost, right? A TPP instead of TAP. That deals with it at the platform level, right? That deals with the service discovery, that deals with failover, that deals with availability zone, deals with federation. If you look at the SIG multi-cluster group, the things around how do you deal with networking between clusters, right? Forget service discovery that I can tell, okay, there's an endpoint there. Well, I've got usually overlapping IP ranges between every cluster when I'm running on Kubernetes, right? Mostly people don't change the 192 or 100.64 ranges that every installer has come with in Kubernetes. How do I deal with DNS registration? How do I deal with any of these things? It's difficult. It is not easy to deal with. We're seeing changes. Antria as a CNI just became multi-cluster support. Cilium has multi-cluster support. We're seeing the infrastructure tooling building those building blocks that a platform can be built on, but it's still not 100% there. But it's amazing to see the infrastructure level changes that are happening to allow this type of a platform to even be able to exist when it does.
And maybe this comes back to what services live in VMs or what services live further down that are core. So maybe there are things like your AAA or your external DNS or your ingress or whatever, and that becomes part of the infrastructure platform itself. Like that is not something that you need to home grow and run in VMs yourself, but it's something that's provided by this TPP, as it were, Scott, that provides services to higher level components in the stack.
Yeah.
So I wanted to just dive back to something that was said earlier. When we talked about the awareness between the different layers of these stacks, I just wanted to ask you guys, like, where are we now, especially in regard to things like TKGM? Are we seeing some of that awareness creep back in, where some of these layers, can be aware of their, the different topologies or how to match things together?
Kind of. We're getting there. I think that, at the most basic level, label selectors is always the way, always an answer for that kind of thing. But I think to tie it into, I think the problem is the incongruous, that I can never say that word, but anyway, between the Kubernetes node, the VM, and the host itself, right? How do you know those are one-to-one mapped? Because the physical reality is, a VM, singular VM, doesn't lose power, a host loses power. So if that host loses power, what nodes does that affect in your Kubernetes cluster? And how do you bubble that information up into Kubernetes? So there are, regions and zones, topology labels inside of at least the vSphere CPI and the CSI now as well, that you can do intelligent placement based on anti-affinitizing based on node labels or region or zone labels. So there are ways to do that, but I think it needs to be wrapped in something a little bit more comprehensive. Sure, you could write YAML that really truly does anti-affinitize stuff, but you really need to know what you're doing. But there's no platform that just does that for you today.
Yeah. So one of the ways we do this in TKGI was you basically split up a cluster into different AZs, define them in BOSH, so the placement of nodes would be spread out kind of equally. But of course, the rules for master nodes are different than for worker nodes, especially if you try to kind of guesstimate how much node capacity you could lose with a failure of X host group, and how many hosts you'd need to based on kind of the workloads you were expecting, and one of the things that that struck me immediately when thinking about this is how the platform administrator really does need to know quite a lot about the application architecture in order to even just to have a conversation with the developers, to explain to them, look, this is how we're going to design the way the platform places nodes. This is how we're gonna actually do taints. This is the topology map that you have to start, that you have to adopt. And when you write an application architecture, when you have these different layers, different pods, different different groups of stuff, this is how you place it. You have to make sure it's in tune. That's the kind of complexity that developers not, they don't like having to think about that stuff. They just want to deploy it. That makes it kind of hard to have those conversations. So I know TKGI quite well, and TKGM I'm a bit newer on. I mean, are we starting to see the same kind of things? I mean, I just want to get a little bit really into the Kubernetes weeds here, just to understand how these placement rules are set up. Because I'm used to seeing this stuff basically be taken care of at the vSphere side, right? DRS rules, host groups, right? Rules. How is this done inside TKGM? It sounds like it's more, the clusters basically spread out, and then we actually just do node pools, basically.
So it does exist. I mean, you have the same capability now as of TKG 1.4. You have the same capability that you had in TKGI of setting up what's called failure domains. Also here, a vSphere failure domain, CRD, and then a vSphere deployment zone, CRD, and then you tie that into your clusters and your KubeADM control planes and your machine deployments and 30 other objects of cluster API, and it works. It is still experimental, the feature in TKG, so that should be known. It works well. I use it a lot. It isn't integrated, for example, though, into Tanzu CLI yet, though. So you have to do some kubectl applies and write some YAMLs yourself for the cluster. I think that the difficulty, though, and this is the same issue I had back in the TKGI days, and this is not a product issue, this is a terminology issue / just a reality, is that, as Myles was hinting at before, we have 3 layers here. In the cloud, we have 2. We have an availability zone and a region. Here we have a host, a cluster, a data center. You have 3 levels here. And in public cloud, a VM is a VM, or a machine is a machine, and then you have an availability zone. You don't have that middleman of the ESXi host in the middle. And one of the challenges that exists is because things like Cluster API, things like Bash, are really built in this idea of being infrastructure agnostic, right? Where we have core Cluster API has this idea of availability zones. Awesome. That works for AWS, Azure, or vSphere, or Google, or whatever other provider there is. Bash, the same way. You can't really add a 3rd layer into there. But availability zones today are host group to cluster, right, would be the availability zone to region, or a cluster to data center. But you then, in either one, you lose a level of abstraction that you actually need for full infrastructure level high availability. You just can't get all 3. You can get 2 out of the 3, choose which 2 you want. That existed, same issue in TKGI, same issue in TKGM. TKGS, it's much easier because TKGS, you can't have it provision outside of a single cluster because the supervisor is in a single cluster. So it becomes really easy there because your 2 levels are the supervisor and the host. You don't have a 3rd level. That could be bad or good. It's good because it makes your decision simple, but you don't have that extra layer that you could go above. In M, you do. But it's still a challenge. I personally go down the idea of host groups and clusters within, my environments. I don't think that cross data center really makes sense in Kubernetes. The main reasoning is latency. I think it was Java Grunt who mentioned here today earlier that latency is the new downtime. Kubernetes etcd does not like latency between its members. For those that have dealt with NSX latency between its control plane nodes, that is much more forgiving than etcd is, and that's not forgiving at all. But etcd is not forgiving. We need to be careful. So keeping things in a data center is necessary. Use a tool like Portworx does great active-active or active-passive between clusters. Use a tool like Valero on a scheduled task to do backups and restores automatically to another cluster to have a standby cluster in another site. Use GitOps with Argo CD, Flux, Cap Controller. Use whatever tools there are, Casten to do, whatever, passive DR. There are different solutions out there to solve this, but don't try and solve it with one cluster to rule them all. Tomorrow I will be saying something completely different than what I'm about to say, but don't try and create a cluster that can handle everything. Try and create purpose-built clusters that are for a specific availability zone with a specific thing. Within that AZ, now try and make sure you get the highest availability you can from the infrastructure without impeding on the applications itself. So set up a host group per host and have the nodes try and split out amongst the hosts as much as you can. But that's also where what you had mentioned, Robert, about the idea of the difficulty of telling a developer, now great, so now you need to add taints to everything, and you need to add pod distribution budgets, and you need to add these 100 things. No, I don't think a developer should need to know how to write a Helm chart. A developer should not need to know what a taint necessarily is, or not how to write a taint. Don't get me started on the syntax and match fields, or anything like that. That should be dealt with by a platform team in a company, whether it's an internal build platform or a solution platform that deals with that complexity behind the scenes. That should not be a developer's job. His job is to build an application. Tell me what you need, and we'll build it according to the platform. Have that be a Jenkins pipeline that adds to every deployment a pod distribution budget. Have it be a Kyverno policy that does that. Whatever tool you want. Don't make the developer take on the complexity because you're moving it up from the infrastructure level to them.
Yeah, you're just pushing the complexity P. You just push the complexity P around the plate, but it never really gets eaten. Someone has to eat it in the end. It doesn't go away. It's still there.
Yeah.
Yeah.
So we're at the top of the hour. I'm not sure if I don't know if this was scheduled for an hour or longer.
Oh, I've run these for much longer than an hour before. Yeah. We've cut some off at the hour also.
Yeah, so because I'm good to stay. I'm just wondering. I'm not sure what Tiffany was what she was expecting. Because there's a bunch of other stuff we haven't even talked about. So I'm good to stay for a while. But
I'm good for maybe 5-10 minutes, but I can't stay the whole afternoon.
Yeah.
You're muted, Tiffany.
You're on mute, Tiffany. We missed your entire intro.
Yeah, the scream and the drama.
Yeah, I was like, no, leave, get off my lawn.
Damn
I was
kids.
saying that I really like this because I'm just like soaking in all the information from all of you. Like, there's just so many like ideas and thoughts and everything. I like it.
Come join the VMware
I'm
user group monthly meeting. Join the monthly VMware user group meeting. This is what it's like every month. And the same people.
I need to figure out what happened to my calendar. I had a calendar invite for that. I need to figure out what happened to that calendar invite.
And by the way, even though we haven't done it lately, for the VMware user group meeting. I love it when people make requests of Myles and I in advance, so maybe we can get expert speakers. We typically need a couple weeks advance notice for that, but I think there's an opportunity to maybe make those better than just this kind of birds of a feather when you said it was the same people every time.
No, it's always nice. Recently, we've been getting some new people coming in, and it's really nice to see. I think as Kubernetes is entering into the enterprises more and more, we're starting to see more interest in how to run Kubernetes on vSphere. I think availability is probably the #1 challenge that people are dealing with right now. I think the next one is air-gapped support that we've talked about as well before, kind of into that in the user group, and how you deal with air-gapped support and all these things where you're not in the public cloud and you have limited bandwidth like Myles has. Right? And it's a great community, the user group, and everyone should come and join because they're just so much fun, the meetings.
A big challenge that we didn't cover here, everybody's been, I think all four of us have been going on about the availability features built into vSphere on the assumption that you've got enough there to build high availability clusters. But an interesting topic that is out there for real are people in organizations trying to support thousands or tens of thousands of edge nodes that could be something like a small retail sandwich shop or something that really maybe doesn't have enough resource to run a 3-4 node ESXi cluster with a vSAN, and yet is interested in utilizing containerized apps. And I think that it hasn't finalized even in the bigger picture of having a full rack of equipment. But when you get down to the edge locations, it is something that VMware is pursuing, but those are perhaps even greater challenges to achieve resiliency, availability. You aren't going to ever get perfect availability, but kinds of things of being able to take a power outage, being able to operate either in, intermittent air gapped, maybe even permanent air gapped, are things that we can talk about too. Maybe in a future one. We didn't get there today, and I don't know that we have time to go there, but interesting consideration.
Yeah,
I got Cluster API vSphere running on ESXi on ARM on Raspberry Pis in my house.
You're the one guy.
No, actually, William Lamb got that working as well. There's a few people that have got that working, but there's some forks of Cluster API out there that can work on ESXi and ARM on a Raspberry Pi 4 cluster that I have at home that works. Interestingly, there's not enough resources in a Raspberry Pi, but I think that the whole ESXi ARM world in VMware and the whole ARM world that's going on is very interesting, especially for edge locations. It'll be interesting to see where that goes. I mean, it's a fling right now, but it'll be interesting to see as ARM is becoming more and more prevalent.
So another topic we could address in the future. We have a whole session just about. We didn't really touch on it today, though we did write it down. Is data persistency, data backup and restore. Persistent data. How do we deal with it? Inside or outside the cluster? If it's in the cluster, what do we do? Valero or other tools? You mentioned a few, Scott. I'm quite a fan of Kasten. Was it Kasten?
K10 Kasten from
K10. That's it. From Veeam. But we could spend a whole another show just talking about a bunch of those products and associated strategies. I put a link in the chat in Twitch to a recent podcast episode of the DevOps Paradox podcast that talks at length about data persistence strategies around Kubernetes and where the kind of the state of the art is there, which I thought was a really fantastic episode. So I recommend people check that one out. But we can easily schedule another talk just to cover some of that stuff. I'd love to talk more about it.
That'd be cool. And then maybe I can start because I've only used Valero, So it would be cool if maybe I could start looking into some of these other things and be the noob of, hey, what's like, how's this one work? Why is this better? What's this do that the other doesn't, kind of thing.
Yeah, it's a very interesting world, and there's a lot of tools coming in there now that are slowly like starting to pop up new backup solutions, new DR solutions, new things in that world. It's very interesting. The other really interesting thing is that about 80% of the tools out there in the backup world all use Valero in the back end and have some nice name around them and added some functionality around Valero. But Valero is de facto, has become a standard in this world. Valero doesn't have a UI. Valero has some limitations, has some things that you have to do manually, and there are tools built around Valero to give it kind of a nicer wrapper. And then there's also completely new things like Cast-En or Portworx that just took completely different approaches to how to do backup. And it's a very interesting subject that I get to deal with on a daily basis for the good, the pretty, the ugly, the bad of backups on Kubernetes. As I was told by a backup engineer, for someone whose job is to do backups at a large company, and I asked him if he could restore a VM for me last year, and his answer to me was, my job is to back up, not to restore. Yeah. It's a fun subject, for sure.
I was trying to find like I had written a guide about getting started with Valero that I was trying to find to post.
I actually followed that when I was starting out with Valero the first time I tried it, because that was the last tool that I actually used in the backup world.
Did it work?
I think it did. I actually think that I have it bookmarked somewhere. I have to see.
Yeah, one caution I'll throw out with that guide, I don't know the particular one you have in mind, but like all things Kubernetes, these things should have a sell-by date because Valero has been advancing pretty rapidly. Just recently with the vSphere CSI driver, snapshot support was enabled, less than 2 months ago, maybe only 1 month ago. And if you stumble upon blogs that were written 2 years ago, maybe what used to be the best way of doing something isn't anymore.
Yeah, I don't know if it's the best way of doing it still, but I do know that as of 2 weeks ago, it still worked.
Great.
Yeah, there's nothing quite like looking back at stuff that you...
Sorry, go ahead, Myles.
Sorry, this is my 200 milliseconds stepping on people. Sorry about that. I was just saying there's nothing quite like spending, a lot of time on something and then 6 months later looking back on it and going, that's out of date, better start from scratch.
I remember I built a whole blog series on the comparison between TKGS, TKGN, TMC provision clusters, and TKGI. And by the time I had finished it and I was going to release it, every single product had gone through another release. And it was completely irrelevant, and I had to restart from zero and never got around to doing it. Forget that, within 3 weeks, everything just became irrelevant. It's fun. In this cloud native world, things move way too fast. It's pretty fun.
Yeah, I don't know how to keep up. I mean, I know I can't keep up. It's just like I just need like it's like cows have multiple like omics and stuff. Or I need multiple brains and just like hive mind.
We need to figure out how to just clone ourselves and then to reunify and gain all the knowledge from all of our clones at once. And then, you can kind of just split out and come back together. Have a distributed brain.
Yeah, and then it's gonna be like Rick and Morty though, and like you're never gonna know which one was the original one anymore.
That's another deep dive topic for backup, actually, having worked on backup products in my earlier career. One of the challenges is that some industries have regulatory requirements or just financial prudence that causes them to keep 10 years or 12 years of backups. Often, theoretically, you had a backup of an application or something that it went through a time machine from 10 years ago and finds that it isn't even tolerant of modern versions of OS to run them on. And I have a feeling that that is something that people need to keep in mind. You know, backing up, if you used Valero not to back up the persistent state of an app, but say Kubernetes itself out of the etcd database, I'm not sure what the guarantee is that you could take parts of a Kubernetes that were 3-4 revisions back and expect them to not be a hot mess should you attempt to recover them into the most recent version of Kubernetes.
Yeah, just don't do that.
Right.
Yeah.
Anyone that's doing backups for long term, right? There are regulations that require this, and regulations are going to need to change around the cloud native world. There's no question about it. It's going to move slowly, but they're going to need to change in this world, because anyone that backed up anything before 120 and comes to 122 when there's no v1 beta 1 of ingress, their restores are going to fail because they were using v1 beta 1 ingresses. Things are going to fail because the CRD they were using, that API version, does not exist anymore. And it's just not going to work. Cas10 has done the most work in this world of trying to figure out how to convert API versions. It's not there yet.
Right. So I think Steve and Myles need to go.
Yeah.
So
I got to jump out. So
yeah. So thanks for this, guys. It was really.
Thank you. We should figure out scheduling a time for doing the other discussion about backups and whatnot. So we should figure out something for that. Thanks everyone for coming. And hi again, Dan, because you're here. And yeah, just a reminder, we have Spring One Tour. Go check that out. Attend some of these, hang out with us in person. And then virtually, starting, I think that's tomorrow, we have .NET Beyond. So come to our things, hang out. Thanks, everybody.
Thanks, Tiffany. Bye.
Thanks, everyone.
Bye.
bye.